Hey guys, welcome back to my channel. In this video, we are going to see how to solve this problem called largest local values in a matrix, right? So it's a LeetCode daily challenge for today. So without wasting much time, let's get into the question first of all. So the question is basically a matrix will be given. Let's say this is the matrix 9981 and so on. And what we have to do, we have to imagine a 3 cross 3 matrix. Let's say a 3 cross 3 matrix is there, right? And this is actually floating around this real matrix, and we are just finding the maximum value inside that 3 cross 3 matrix, right? So let's say this is the first 3 cross 3 matrix. So in this matrix the maximum value is 9, right? The maximum value is 9. So we took that, and then I'm just floating this to the right hand side, so it will become like this. So the next 3 cross 3 grid will be forming in this, right? So in this, what is the maximum value? The maximum value is 9, right? So we are just picking that also, then we are placing here, right? Then we are going one step below, but make sure that you start from the left to right, and then left to right, and then top to bottom, right? So here we have seen all the left to right possible positions, and then we have come one step, downwards, and then we are floating it again from left to right, right? So it will come here. So 5, 6, 2, 8, 2, 6, 6, 2, 2. What is the maximum value? Maximum value is 8, right? So we are writing max equals to 8. Then again I am floating this to the right hand side. So the 3 cross 3 grid will be forming in this area, right? So here the maximum is 6, right? So that's what we have to return. We just have to take all these maximum values and then return it, right? Okay, so we got the question, but we don't know how to go about it, right? So see, how I'm going to approach this is basically, I will go to the middle element, right? I will go to the middle element, and then I will check whether its neighbors, whether its eight neighbors are present or not. If they are present, that means this can form a grid, right? So for example, I cannot consider this as the mid. Why? Because see, right hand side it is there, bottom right also it is there, then bottom part it is there, but what about this part, this part, this part, this part, and this part, right? So these are not forming any valid indices, right? So that's the reason I'm not taking this as the mid. So I cannot form a 3 cross 3 matrix using this index as the mid, right? So I will move forward. I will try for this. This also I cannot do. Why? Because see, these values I cannot form, right? So I will go to this. This I cannot do. I will go to this. This also not possible. I will go to this. Not possible. I will go to this. This is possible. Why? Because see, all the neighbors are present. That's the reason I can form a matrix around this index, right? Then what I'm going to do, I'm going to get the maximum value, right? Maximum value in this grid, and then I'm going to store it in a vector. Let's say I'm keeping a vector for this row, so I'm storing it like this. Then I will move forward. Then here comes 2. For 2 also I can make a matrix. Why? Because see, all the 8 neighbors are present, so I will get the maximum value, and then I will add it to this row matrix, that is 6 and 2, right? So once this row is completed, I will add this row, that is 6, 2, to the actual matrix. Then similarly, I will go here, I will go for 8, not possible. I will go for 2, it is possible, right? So for 2, these all are the 8 neighbors, I will get the maximum. And then for this row, I will maintain this row vector. So 8 will be added, which is the maximum for this. And then I will go to 6. Of course 6 is also possible. Why? Because all the 8 neighbors are present, right? Then I will get the maximum value and then store it in the row vector, right? So 8 comma 6 will be this row vector. So 8 comma 6 will be added to the main vector. Sorry, here I have taken the indices, right? We don't have to take the indices, we have to take the maximum value, right? So 9 and 9 will come here, right? So the final matrix will be 9, 9, 8, 6. So that's how I'm going to approach this problem. Okay, so now we got to know that after going to a particular index, we are going to its neighbors, right? So how to go to their neighbors? For that, let's consider this, let's say x comma y, right? X comma y is an index. So who all are the 8 neighbors? Who all are the 8 neighbors? These all are the 8 neighbors, right? So it will be x minus 1, y minus 1, x, y minus 1, x plus 1, y minus 1, x minus 1, and so on, right? So can I write this something like this? Let's say x and y is there. So the indices will be increased by these values, right? So see, if x comma y is the index here, this index will be x minus 1 comma y minus 1, right? So I'm just going to subtract 1 from x and y to get this index, right? So similarly, I'm going to add 0 from x and subtract 1 from y to get this index. Similarly, I can do these operations to get all these neighbors, right? So if you have an observation on this, can I say these all indices, these all values are all the possible combinations of two values from these three values. What do I mean by that? Minus 1 and minus 1, right? This and this, let's say this and this. So minus 1 and 0 is also there. 0 and plus 1, right? 0 and plus 1 is also there. Let's say plus 1 and plus 1, plus 1 and plus 1 is also there. So similarly, I'm going to get all the combinations of these two values, right? So that combination will be these values. So these will be all the combinations that are formed from minus 1, 0 and plus 1. So how to generate these indices, right? So how to go about this? So let's say I'm calling the first value as I and the second value as j. So to generate all the combinations, I'm just going to iterate I from minus 1 till plus 1, and then same thing for j from minus 1 till plus 1. And I can say that I comma j is a neighbor, right? To be specific, I comma j is not the neighbor. To be specific, I comma j is not the neighbor. Let's say x and y is there. So x plus I and y plus j will be a neighbor, right? So this will bring me all the possible neighbors, 8 neighbors, right? 8 neighbors. Okay, so now we go to know how to find the neighbors, right? So if you recall that what we basically did, we actually checked whether this is valid or not, right? Whether these neighbors are valid or not. So how to check whether the neighbors are valid or not? Can I say, let's say this is the grid and here I'm standing right now. If this is valid, this is valid, this is valid, this is valid. Can I say this grid will be a valid grid? True, right? So that's how we are going to find it. So we are going to check for this, and this. If these 4 neighbors are valid, that means 3 cross 3, we can form a 3 cross 3 grid around that index, right? So what I'm going to do, I'm going to check. How to check? I'm going to check if, let's say, I and j will be my current position. So what I'm going to check whether this index, that is the ith index, is in between 0 and row minus 1, right? Let's say row is the size of each row. I will check whether I is in between 0 and row minus 1. Similarly, I will check for j. If it is in between 0 and column minus 1, that means this is a valid neighbor, right? So I will traverse through all the neighbors through this technique, and then for each neighbor I will go and check for this particular condition. If it is satisfying, that means it's a valid neighbor, right? So let's see in this matrix. Let's say I'm standing here. This is there, but this is not there, and this is not there. What I can say, I cannot form a 3 cross 3 grid around this 9, right? So I will go and check for the next index, right? So I will be standing here, then I will check for these four. Okay, these 3 are present, but this is not. So again, keeping this index with me, I cannot form a 3 cross 3 grid. Then similarly, I will go and check for 8. This is also not possible. Why? Because see, this part is not there. Then I will check for this and this part is not there. And then I will come to 5, but this part is not there. I will come to 6. This is there, this is there, this is there, this is also there. So what I'm going to do, I'm going to traverse through all these neighbors and then get the maximum value, right, including this. And I'm going to store that maximum value in a row vector, right? So in this row I found a value, and then I will go for this also possible. Why? Because all the 4 neighbors are present, so I will go for these 8 neighbors. Then I will store the maximum value in the row vector, and then after completing this row I will push this into the main answer. So similarly, I will go and check for all these indices whether their four neighbors are present. Four neighbors, basically what it means, whether this, this, these indices are valid. That means I can go for the maximum value. Otherwise, I cannot go. Right, so let's look into the code. So this is the code, and this row represents the size of all the rows, and this column represents the size of all the columns, right? Columns. So I'm going to create this vector called answer. So in this answer, I will be pushing my answer rows, right? So I will go to the first row, and then I will declare for this row, I will be storing all the answers in this current row, right? Current row. Then I will iterate through all the columns in that particular row, and then I will check for the 8 neighbors, right? So how to check for the 8 neighbors? I will go for this index, this index, this index, and this index, right? Basically, I will check for the 4 neighbors. So I will check I minus 1 is greater than 0, I plus 1 is less than row, then again j minus 1 is greater than 0, j plus 1 is lesser than row. If these all conditions are satisfied, that means 4 neighbors are in the range of this matrix, right? In this matrix. If that is true, I will just find the maximum value and then store it in the current row. So after completing each row, I will check whether this current row is having some elements or not. If it is, then I will push this current row vector to the main answer, and then finally I am going to return this answer. Right, so let's see this part. So I'm going to traverse through all the 8 neighbors and get the maximum value, right? So how I'm going to traverse? I'm going to keep k and l. So this k starts from -1. So this k will have -1, 0 and +1, right? And also this l will be having -1, 0 and +1. So at the end, I will be getting all the combinations of these two, and this I plus k and j plus l will be giving the neighbor indices. And then I'm going to store the maximum value inside this maxi, and at the end I'm going to push this maxi into the current row, right? So coming to the time complexity of the solution, we are going to each and every index, right? So it will be O of n square, and then for space complexity we are not using any extra space, so it will be O of 1. So that's it for the video. If you like the video, hit the like button, subscribe to my channel. Until next time, see ya.